All right. It's 8:10. Exactly 8:10 right away. So we are starting now. So how many of us enjoyed the session last yesterday? I mean, you enjoyed the session yesterday. Can you give us? Okay. All right. Who else? Who else enjoyed the last session? Okay. So anyway, you'll be able to watch the videos. That's fine. All right. So moving on. I'm going to continue from where we stopped. So we started talking about Python in yesterday's class. Okay, so we did a lot of we did this basic program in Python, and I said we're going to dive into. We're going to continue from there. Alongside, we're going to go into robotics today. Okay, so you can have something to continue with tomorrow. So if you can see my screen, yeah, please give me thumbs up if you can see my screen, please. Thumbs up if you can see my screen, please. All right, thank you so much. All right, so moving on, I'm going to proceed. I think we stopped at page, yeah, we printed hello world, and this was the assignment I was given, and I don't know how many people were able to do the assignment successfully. So we talked about some comments in the last session. We talked about the print statement in Python, which is used to produce the output of your code, and many others. Yeah. So now we're going to dive into the comments. Okay, we talked about comments, yes, where I told you that comment is something you just use to remind yourself of your code. You use as symbol. Remember, Python interpreter ignores the comments, okay, and helps document your code. It's just for documentation purpose, for you to know what you wrote in the nearest feature. So you don't write a code and you wake up in the morning and be like, is it me that wrote this thing? What is this? What does this thing do? So the comments will help you to know that, okay, this is what it does, so you don't have to crack your brain so much, okay, to be doing that. So you see that the problem that is being solved there, like I said yesterday. So even as a developer, you also have problem being solved in your code, so you need to understand what you wrote. Then the second syntax I want us to know in Python is this indentation. Now there are some key features in Python that helps you to know that, okay, how I put it now. Okay, let me just read what you have here. Python uses indentation to define the structure of your code. Unlike other programming languages that use curly brackets or keywords, Python relies on consistent indentation to indicate blocks of code. By convention, full space or a tab are used for indentation. Indentation is crucial for defining nested block of code, such as loops and functions. Now, in Python, we have loops. Now, when you say the word loop, what does it mean? Something that works or that does what it's doing continuously without stopping. It does it continuously. It's like it goes in a circle. It keeps on going on and going on, keeps on repeating itself. You understand? It keeps on repeating itself. That's what loops does. Yeah. So that's that. So in Python, one wants to have something like indentation. Now indentation is like this. Now this is an indentation that's giving a required number of space before your code. This line of code, I want to read this now. If x is greater than 5, print this. Now you see that there's space here. Now this space, I tell you that this statement here, print x is greater than 5, is not standing on its own, but it belongs to this if statement. That is basically what I'm trying to explain to you now. how what indentation is used for. To tell you that this particular line belongs to this one is not a standalone code. Now in your code, let me open my Python IDE, and once again, if you are using the online platform, coming. If you are using the online platform, I'm going to send the link again, so you can be able to join us with it. Once again, if you are using the online platform, that is it. So in your code, yeah. Now this default code, you also open in Python, like you see this. Now this should tell you that if I put this thing here, this is any code that is starting in the first, we have this is the first line. We also have some space here and all that. Now this code at the extreme left of your code, of your extreme left of your line of your code, that is where your code is your code is meant to start. So if you give a space in it, meaning that there's something that you want to do that's in front. Like for this one now, you see this thing now. Once you put a semicolon, this is a function. You know what he wrote here is such as loops and functions. So this is a function. Now this is not a loop. A loop you have for loop. You have what's this? You have for loop. You have while loop and all that in Python. Yeah. So this is a function now. Define is a function. Tell you that define. Now this return function is telling you that this return function belongs to this definition here. It means it's returning what is defined here. That is why you have it like this. So once you use a semicolon, Python automatically lets you know that okay, maybe you want to do something like this. So it gives a 4 space. You see here 1 or a 1 tab. In this case, it's 1 tab, but it's usually 4 space, as you can see here 1, 2, 3, 4. So it normally gives 4 space on 1 tab. Tell that this particular the second line of code belongs to this first line of code in your Python. It's like a subset. I didn't want to go a little bit advanced because I'm trying to give you the basic understanding, because I can see that many of us are kids here. So for those of you that are not maybe you are just beginner in it, it's like a subset of a particular code, a particular line of code. That is what it is. Okay, that's what the indentation is used for. Tell you that this one should be what is part of it, is not standing alone. Okay, so when you now write your next line of code, which is the else, like if else, you know, we have in Python, you have like conditional statements. If no, let me do the basic. What I normally tell kids: if you are hungry, okay, we did that yesterday. Now, if you are hungry, you go to the kitchen, right? If you want to watch television, you go to the sitting room. Now, you see that I used that word if yesterday. I'm using it again today. If you want to do this, you go here, right? So the condition is you must want to go there. So in this statement here, if x has to be greater than 5 for it to print what a particular thing. That is for this set of line of code. So if you want to watch TV, you go to what the parlor. So that if you want to watch TV, it's your statement, is your conditional statement there. So now what is going to happen if I want to watch TV? What should I do now? Going to the parlor to watch TV is now this print statement here. So that's going to be part of watch TV will be under it, because it has to come under, like I can't just watch TV without going to the sitting room, because I need to go to where the TV is, right? So I can't go here without going there. So the first thing is your condition will be there. Okay, if I want to do this, if I'm hungry, I go to the kitchen to get the food. The food don't just appear to me, right? So do you understand what I'm saying, guys? Hello kids, do you hear me? Do you understand the indentation now? So there must be something on it tells that it's on this, it belongs to this line of code. Do you understand? Alright, good. So let me just proceed now. Then when we talked about the print statements in Python, that's the function is used to display output. Some of you that did the assignments and did it excellently well, that's good. You're correct. So you need to print the output of your code on the console. It allows you to output the text and the value of variables. You can pass multiple arguments with the print statements and all that. You can pass multiple these things here. So now I think variables is going to be, yeah, before we talk about data types, variables is going to be the last syntax. Now the variables are used to store, I believe we all got this print statement. We did it yesterday. We all got this print statement, right? Give me a thumbs up if you understand how the print statement works. How the print syntax work, print function. Hello, thumbs up. We already did it yesterday though. I don't want to pass it without us not getting it. Alright, good. Okay, thank you very much. Okay, so moving on, we have variables. Now variables are used to store and manipulate data. Now variables are like yeah, I can see your hands and the thumbs up and the reacts. Variables are like see variables like a box or a basket. I want to imagine, I would have said close your eyes, but I don't know if you are closing your eyes. I want to imagine a box. You have a box, and what do you want to put inside the box? You are relocating to Canada, and no many of us want to go to Canada. I get to Canada, so you have a box and you want to put some things there. Now when you put, let me say, breakable cups or plates, you put them in the box, and since you are relocating, for you to know what is there, yeah, you label it, right? You label it with breakable plates, or you label it plates. Am I correct? Yeah. So you label it like, okay, this is plates. You have another carton. This is this is that. So now I can decide tomorrow that, okay, when I get to Canada, I want to relocate to where now? To Germany. That same carton, I can decide not to use put plate inside anymore. I can start to put shoes inside, right? I mean, it's my carton. It belongs to me, right? That's how variable works. Now, why did I say this? When you hear the word variables, it means it's bound to change. It's not the same. It's not fixed. It's not permanent. You can change it when you want to. That is the meaning of variables. General meaning, you can change it when you want to. So you see it like a box, like something that you can have to see. Today you want to put oranges inside the basket, or then tomorrow you want to put clothes. Yes, tomorrow you say you want to put maybe wires inside. No, just think of anything. So that's how variable works. It's like a box that you assign it to. Like, okay, this today you belong to these things. These things are what I want to store inside. I want to store books inside this carton today. Store it for me. Fine, I will store it. Python will say I will store it. Tomorrow you say, okay, I move the books. I don't want books anymore. But the same variable name, yeah, the same variable name called carton, I want you to store what? Clothes. Python will say I will what? Store it. Oh yeah, I move it. Say carton. I want to store what now? Carton. What can you store in a carton? I want to store bottle of water. I'm looking at the environment. That's why I'm trying to think. I want to store bottles of water inside. Python will say what? Carton. Store what? Bottles of what? Bottle of water inside me. I need to do that. Okay, that is it. That's how it works. So in Python, you don't need to declare the data type explicitly. Don't worry, we're still going to have type of questions. You can assign a value to a variable using the equal sign. So you use this one symbol to assign that this thing belongs to this thing. Okay, this one belongs to this one. I don't know, I think there's one person that has always been consistent here. So is it Opeyemi now? I don't know the name of your child, but let me say your child's name is John. John belongs to Opeyemi, that kind of thing. Do you understand? So John is a child and belongs to that person. You understand? So it's like I'm assigned to you. So whatever I ask you to do, it's whenever you call John, it means I'm referring to Opeyemi as the child of what? Opeyemi. That's the meaning. So it's like you belong to this person. So whenever it's like equal to, okay, let me not use child now. Husband and wife. This one belongs to father, belongs to mother, mother belongs to father. By belonging, I mean they are. Whenever you say daddy, I'm talking to mommy too. 1 + 1 is equal to 1 in marriage, Abby. I'm only to talk about marriage. So the point is this: whenever you call this one comes too. You're referring to this, so that's variable for you. So in variable, like now this example, you have x is equal to 10. So whenever I say Python give me x, Python will not give me x, it will give me 10. Why? Because I've already told Python that x now is now what? 10. So whenever I say x, any line of my code, it will print what? 10. So if I say x is equal to hi, welcome to class today, whenever I say print x, it's going to print what? Hi, welcome to class today. Let me show you. Too much talk. Let me do that for you now, so you see it. I know Emma has talked too much. Okay, so I say x is equal to hello everyone, welcome to class today. So I say x is equal to this, and I say what, print x. Okay, now let me print this statement now. Let me just run this code. Now I didn't ask to print to, I just said x is equal to what, hello everyone, welcome to class today. Now what happened? I don't have any error on my code. Neither do I have anything executed. Why is that so? I don't have time. I would ask someone to tell me why. The reason is because I didn't tell it to print. The print function is to tell Python that, okay, I want it to give me the output of this. So I just told it to store it for me. So it's just storing hello everyone, welcome to class today as into variable x. That's all it's doing for me. It's not doing more than that. So since I want it to print it, okay, since I want to print it, I have to tell the Python that, okay, I want to print it. So I will say print what, x, and I say print x, okay, and I press my run key. You will see that it's not going to print what I said to print x, but what is it going to print for me? Come on Python, ideally don't waste my time. Internet is bad, network is poor. Okay, let me use the offline. Oh yeah, I don't have time again. I'll ask someone to tell me why do you have an error. I mean, I said to print x, and it's also saying what, x is not defined, but I defined x. I said x is equal to hello world. Now one thing about Python variables is case sensitive. Now the x I said that belongs to hello everyone, welcome to class is capital letter X, and what I asked to print is what, small letter x. So he's seeing x as a variable, but he doesn't know what x is. Why? Because it's small letter x has to print, and the small letter x was not assigned to anything. So that is why I have an error here saying x is not defined. He's seen x. Okay, you mean x is a variable, fine, I get that, right? It's a variable, yes, I know, but you didn't tell me what this small letter x means. But however, you told me what character x means, so that is why I'm going to change this to what, character x, okay, and I run the code again one more time, and you see that I'm going to have the output of the code. I'm not going to have an error now. Why? Because I asked to print what, the variable x as capital letter. The network is bad though. You don't understand his network. Let me copy my code and I'm gonna run it on offline. So I have something like this. Sorry, I have to use the interactive mode. Has it load now? Let me use the I told you guys yesterday we have the script mode and interactive mode in Python. So I have to use the script mode for this. So I'm going to save my code. I'm going to save it to print x, okay, and I run the code. You see that the code has said hello everyone, welcome to class today. So that is our code there. This is network. You see this is network issue, problem in connecting to server. Let me run it again and see. I hope it will go. So that is that. So in your Python, ideally integrated development learning environment, that's meaning of ideally, you need to be specific. Okay, that's right, now network is good, hello everyone, welcome to class today. So your variable is case sensitive. That is, if you are using lowercase, you are using lowercase. If you are using uppercase, you are using uppercase. Whatever you use, always try to know the kind of case you are using and know that, okay, know where your error is. So don't panic. I mean, I panicked. I didn't panic. Why? Because I know that, okay, something is wrong, and what is wrong here is that I asked it to print what, small letter x and not capital letter x. That is why I try an error. So do you understand that? So in your variables, you need to be what, conscious of your what, the kind of type data variable name you use. whether it's capital letter or small letter, just like passwords is what? Case sensitive. Are we clear on this, please? Can we proceed? Okay, I said 8:30. I'm going to robotics because I want to attend to questions. Okay, so before I continue, let me just use 5 minutes to attend to any questions before I dive into robotics. So let me pause here. I want to have the questions. If you have questions, please, this is the time to ask your questions. Now is the time to ask your questions, please. Question time. Drop a question on the income message while I'm trying to get to our slide for the robotics class. Okay. So questions, please, on Python. Before I go into this, I'm going to pause here for now on this Python course because you see that it's a whole lot. So questions, please. If there's no questions, I can continue on this thing. Put a question on the income message. Hello, question, please. If there's no question in the next 2 minutes, I'm going to continue. Alright, if there's no question, give me thumbs down. If there's no question, give me thumbs down. Not thumbs up. Thumbs down. Okay. That's one. No question from one person. We are about 7 people here. So okay, John, no question. Good. That means you all understood what we're explaining. I'm happy that we all understood everything. Good. Alright, so who's ready for robotics class? Alright, let's proceed. No more talk. Alright, so okay, so no other question. Time for questions is over. Let's proceed. Now, when you talk about robots, I know many people, when you hear robots, many of them what goes through their mind is a human form of robots, like a human form structure, this kind of thing, right? When you hear robots, you see something like this. In a human structure, something that moves left, right. I wish I could show my camera. Left, right. I mean by this, but no. Robots is not just that. Don't limit robots to definition of robots to these kind of things. Yeah, fine. They're right. They're robots too, but they're not limited to this. This is a robot. This is not a human structure, right? But this is a dog. This is also a robot. This is not a human structure, is it? Right? So don't limit robots to only things like this. Now, what is a robot now? When you hear robot, what comes to your mind? Robots is, take note, robot is anything that can work, that can function, any electronic device, okay, that can function without human supervision. I don't know if anybody got what I just said. Without what? Human supervision. Without any human being controlling it. For example, how many of you have gone to a mall rather, or a shopping complex, and once you get to the entrance of the door opens for you by itself? There's nobody that is there to control it. It just opens. No human being pressing a button. You're not going to press the button to open it. Yeah, I can see one person raising up on there. So that is it. Another example is maybe a smart dustbin, whereby you just walk close to the dustbin. I know many of us will love this one because there are a lot of germs. People are creating. You see, I told you guys yesterday that in what do you call it? In programming, purpose of programming is for you to be able to solve a problem, right? Now, someone have talked about this thing that there are germs around. I mean, on the trash can, if you want to use the trash can, you have to open the dustbin and throw your dirt, right? And then close it back. That way germs will enter your hand and you can't use that hand to eat and you get disease, right? Now there's a solution to that. Now someone brought up that, okay, how about the dustbin opens by itself? I don't need to open it myself. I just go close to the dustbin and it doesn't open for me, and I'll throw my trash can gently, and whenever I leave I don't need to close it myself. It open for me, let it close by itself, right? That is what a robot. Why? Because I programmed it to do what I want it to do, right? Without me controlling it. I'm not the one that's going to open the dustbin for me, for me to throw my trash. The dustbin will open by itself. That's the robot. And I said to give more examples, but we don't have enough time for that. So any electronic device that works, that is programmed to work without any human supervision, is a robot. You have some things that you move around. You must see in cartoons that you send robots to just, all these machines that just work on their own, right? They just go for an errand, give this to this person, and because it's programmed to go for errands, when it comes, it delivers the message and it comes back. Those kind of things. And even automated devices. I know many of us who like houses. You must have seen gates as well that opens. I mean, cars, or gates for cars that opens for the user, for the owner of the house. So I know many kids now love to do something like this for you. I know many of us want to do that. Build some things for your dad and mom that you not have to be opening the gate all the time. Opening the gate is stressful. So just give it a control and it gets opened by itself. Senses that the car is this, maybe to scan the car and say, okay, this is the plate number, for example, because plate number is what they use to identify cars, right? So it scans the plate number. Okay, this plate number belongs to the owner of the house, so it opens. So if it's not this plate number, it does not open the gate for the person. That kind of thing. This is something that people just think, right? You just think outside the box and be creative. That's one thing I just said about this thing now. I don't know if it exists, but if it does, beautiful. But if it doesn't, I can start to build on that. So that's one big thing about programming. It helps you to expand your brain to think outside the box. So that's that. Enough of that. So now, what are the things that we use to build this robot? What are the equipments, the items we use to build it? Don't mind me, I'm skipping all this. This is in our stories. Now, just like a human being, we have brain, right? Robots also have what? Brain. Now, one of the brains that the robots use is what? Arduino. I mentioned yesterday that we're going to go into Python on Arduino. One of the brains robots use is what? Arduino. Now, this Arduino has everything, just like my hand, what I'm saying now. My mouth is connected to my brain, like my speech, my knowledge, and everything is connected to my brain. So as I'm talking, it's from my brain. Every part of my body is connected to my brain. If I want to move my left leg, it will send signal to my brain that it wants to move left leg, so the left leg will now what? Move. Okay, so everything is being controlled from the what? Brain. Just like human beings, robots also have brains. And the brain of the robot is this. One of the brains is Arduino. We have different kind of brains for robots. They are called microcontrollers. Okay, and one microcontroller is what? The Arduino. Now Arduino is what? The brain of the what? The robot. Now, looking at the Arduino board, you have this is where you write. I told you program robots, right? So you write your code, you upload it through this USB port 1. You can see this label here, 1. And you have the power cable. Let's say you upload your code. So when you upload your code, you are uploading your instructions to the robot. Okay, so everything you told the robot to do will be stored inside this board. This Arduino board. This is a board. Everything is being stored inside this board. So when you now decide to execute it, you need to power it, of course. The robot don't work on like human beings that don't work without power. We work on energy of food, and if you have strength to talk and all that. But thank God for God, we are humans, right? But robots, they need electricity, they need power. They need power to work, right? So when you've done that, you either use a battery or you use a direct light, just like normal lights, right? So to do that, you connect it through this number 2 here. So when you're operating your code, everything, all the instructions is being stored here. But for it to work, you need to connect it to source of light, either a solar system, anything that generates power. It needs power to work. So now, when this is the brain, right? All right. Now, just like humans, my brain cannot work without my hands and my legs and my mouth and every part of my body. The brain needs to work with other parts of the body, right? Similarly, the Arduino board, the brain of the computer, the robots, you can see this is just the board. It needs to work with other parts of the body. Now, what will not be the place? How will you connect these parts? After you have all these pins here, you have digital pins and analog pins. To connect, you connect all your functions. For example, now if I want to build a robot, a smart dustbin that operates by itself, I will have my brain on my computer, right, of my robot. Now this brain, after I put in my code, I will connect it to these pins here, connect all the parts, what will make the dustbin to open and what will make the dustbin to close, what will make the dustbin to see this person that is coming. I will connect it all to all these pins here according to what I program on my code. So when I connect everything, then to start working. If I just open my code and I put it on the board and I put it on the dustbin, I say, oh, yeah, start working. It will not work because it does not have what to work with. It needs, just like my brain needs my hand to carry a laptop or to carry something. It can't just carry something like that. It has the knowledge of carrying it, but it cannot work without the physical other components. Okay, other components of my body, and it needs the components of my body to work. That is that. I don't know if are we clear on this now. The brain, are we clear on it? This is the brain of the world's robots. Are we good to go? Are we good to go, guys? Hello. All right, thank you very much. Okay, so now moving on. These are just some explanatory stuffs on what's the components on the brain of the robots. I don't want to dive much into it. We have less than 15 minutes and we still have a whole lot. So you're going to continue. You can continue tomorrow. So please, parents, I encourage you once again to join. Tomorrow is the last day. It's just 1 hour. Please join your kids so that they'll be encouraged to learn, and also you can help them jot down their questions. All right. So this register color code. This is a whole lot. But it's not for this class. I'm not going to talk about it in this class because it's going to take a whole lot of time to explain. So peradventure in future classes I'm going to do that. So okay, getting to know your tools. Yeah, it's talking about the tools. Okay, so now I mentioned yesterday about programming languages. All right, just like our Python, I told you that to print hello world in Python is different. If I showed you, not just tell you, I showed you to print hello world in Python is different from printing hello world in other programming languages. Likewise in Arduino. Now all programs, I can't go and write Python inside Arduino just like that. Python does not Arduino does not understand Python. The language that robots understand, for in this case the Arduino board, is what? Arduino programming language. Okay, and to get that installed in your computer, don't worry, when that time reaches, we'll talk about it. So it needs that software. It needs the software because that's where you write your code. Let me show you what the software looks like. Let's be loading. So it needs that software to be what? To write your words, your code. So that's why you just like you have Python, and you write your code in Python. In Arduino IDLE, Arduino understands what? Arduino programming language. Now Arduino programming language is a combination of two programming languages, C and what? C++. So these two programming languages came together and form what? The Arduino programming language. Okay, so this is just how to install it. It's a very simple step to install Arduino. It's not difficult, trust me. So don't mind me. I'm not skipping. What I'm skipping are things that are not really important as much. Okay, so this is the IDLE. I'm trying to load it so that we can be able to see it very well, but since it's taking time. I don't know why it's taking so much time. It shouldn't take this much time. Okay, why you are waiting for it? Do anybody have any question? Anybody have any question? Any question? Any questions so far? So this is the software anyway. This is source. So these are just, you can see it's used to what an open source code supported by Arduino.cc community hardware blah blah blah. Just any question, please. Okay, so I'm going to now let's talk speaking about components. Yeah, drop a question on the in-call message, please. Drop your question on the in-call message. Please drop your question on the in-call message. Okay, so now we're talking about the components. Now I told you that the Arduino board will not just function on its own. It needs some other things to work, like the hand and the legs and all that, right? So looking at it, we have the piezo. So let's say you want to create an automated alarm system whereby if someone comes to your house and wants to rob your, let me say a thief is coming to your house, God forbid, there's no thief that's coming to anybody's house, but my point is, so okay, let me say unwanted guests. Yeah, I think that's the best way to say it. An unwanted guest wants to enter your house and you have your house secured with PIN, password, and you type a password. You type password to enter the house, and the password you enter is 1234, and the person keeps on typing 12351111, and you program your door that if the person tries it 3 times, it means the person is not the owner of the house. You should throw an alarm. So you use this alarm system. This is to create noise, as you can see here. So it's called the piezo, or we call it the buzzer. So it's used to create noise. Okay, so this is one component you use. So when you type your code on your, of course, your programmed number pad, okay, when you press the code and the computer and you use the person that enters it is not correct 3 times, since you program it that if the person has 3 trials, so after 3 trials it will create an alarm. It will alarm everybody, so everybody will know that okay, someone is trying to enter the house that is not the owner of the house. Okay, so that's that. So you see that I don't need to come and press alarm. It's just what? Alert. Or let's say you want to enter, you have a guest, you want to know that a guest is coming as well. Now this is not a wanted guest, now a guest is coming. So for it to know, instead of you going to check the door all the time, so once you can know the person, know that someone is coming from a very far distance, you can create a small alarm system in your room and say that okay, let me say if the person is like 5 meters close to my door, alert me. So I'm inside the house, so once the person is 5 meters, it just alerts me. So before the person gets to the door, I didn't know that someone is coming, so I'll have it in mind. That is automation, right? It's smart. I didn't need to go and manually go and control it. Okay, so that's that for that. So that's the alarm system there. So this is not the resistor, please. The person that built this project didn't do well. This is not a resistor. Okay, so this is the Arduino board. Like I said, this picture shows the Arduino microcontroller board that will be in the center of your project. Yeah, I told you it's the brain of the project, right? It is a simple computer which you will use to build circuit and interfaces for interaction. So it is what like you use to communicate to other components of your world. You see, it's the other components. Interface other to control other components on your world, on your board, on your project. Then you have the light emitting diode. For example, now I don't know, I'm not a traffic person. I don't know if any parent here is a traffic warden or has any idea about traffic stuff. Now I if what I see, I will say the traffic lights that we see in Nigeria roads, it's automated, is a robot. Why? Because if it is so, hear what I said, if, because I'm not working there, I don't know. If nobody is manually pressing the control, they're timing it, then I will say the robot. If it's doing it by itself automatically, nobody is controlling it, it's the robot. If what I'm seeing, if what we see on a daily basis is what is there as it is, then I will say the traffic light is a robot. Why? Because after a particular number of time, after it counts down to 0, it changes the light from green to what? Yellow to red, then from red to yellow to green after the time. So you can build a sample project of a traffic light using the LED, light emitting diode. So you can have a combination of, you can see they have different colors. Let me zoom in so you can see it very well. You can see you have different colors here too. You can have there are many colors. You have RGB colors, red, green, and blue colors. You have different colors so you want to use for your project. So you have the red, the green, and the yellow, right? So you can copy, bring these three, and be the basic. If you check the pictures that I sent to the group, you see that some people did one of our trainings. We did hands-on traffic light system for people to just a sample. So you can use the light emitting diode for that. Okay, so then before I say something, I'm not going to talk about resistor color code. Let me just tell you one or two things about resistors. Now resistors are used to not to stop. Either the word resist. When they say resist this person is evil. Resist this person is bad. Now that word resist is like saying to stop following the person. But in Arduino, resistors they will not completely stop the flow of current. No, but to what? Reduce the flow of current. Now let's say you have a project that wants now resistors like, okay, you have a project and you don't want so much current. Let me say you want 100 voltage, and what is coming to the code, let me say from the power, is like 300 volts. Now what the resistor will do is it will reduce that 300 volts to what? To reduce it for you to the capacity to be enough, so that your project will not spoil, so that your code will not blow, your entire work will not be damaged. So it will help you to reduce that flow of current. Okay, reduce the flow of current to a particular level and be able to work with the rest. That's resistor. Unlike resistor, capacitor works similarly though. We hear difference between resistor and capacitor. The only difference between resistor and capacitor is that instead of reducing it, okay, see what I wrote here. When the circuit voltage is lower, the stored charge is released. Now, what does the capacitor do? Unlike resistor, it doesn't just reduce the flow. Resistor will reduce the flow and throw it away, but capacitor will store it, so that when you now need more of it, it will now what? It will now release the rest. You can see here, when the circuit voltage is higher than usual, it is then stored in the capacitor. It will just reduce it and what? Store it there. Okay, it's used to store and release electrical energy in a circuit. That's what the capacitor does. So it used to store current and release it when it is what? Low, when it's needed. Alright, so are we clear on that? I think I'm going to stop here for this class, and we'll continue tomorrow. Our class continues tomorrow. Our session continues tomorrow, please. And tomorrow is the last day for our free sessions. So please, any question now? Okay, how can I get the Arduino board? Alright, if you want to get the Arduino board, just let me know. Come to my DM, I will talk about it. So I will answer the question on PME. Come to my DM, we'll talk about how you can get it. So someone said, are all robots made up of wire? Well, not all robots are made up of wire. We have wireless devices, right? We have wireless. If I'm getting you correctly, you mean internally. If you mean internally, yes, because you can. It must not be all the components that are made up of wire, but definitely you need wires to get some things connected. Okay, like you have wireless, just like your Bluetooth device, right? I can decide to build a system that works with Bluetooth, but then I still need to use make use of some wires. Now those wires, I need to talk about the wires. Now the wires you use is not just live wires. We have some special wires for simple projects, not for real-time projects. For simple projects, you use them. They call jumper wires, whereby you can eject the wires and put them back, just for testing purpose. Those are the wires you use for a simple project. So I can create. If you have a question, please don't just raise up your hand. Drop your question on the in-call message. I will attend to your questions now. I'm attending to the questions now. Okay. So that's that. I've answered the question on PME. So robots they have not entirely. It's not necessarily that every part of the robot is made up of wire. Okay. All right. So yeah, this is a code I was trying to work on. This is how the Arduino ideally looks like. Okay. This one is still loading. This is the same thing. Okay, yeah, this is another one. It's the same but this is the updated version of the Arduino IDE. This is another line of code. Don't look at it. You may not understand what is here. You may not understand what is here, but it's just a simple. It's a simple traffic system, traffic lights. And I'll show you guys real time, but we can't work on that now. Okay, so question please. Question. I'm waiting for our questions. If there's no question, we'll continue tomorrow. We'll continue our sessions tomorrow. So questions please. Questions. How will the code get into the robots? Good. Now I explained here that the code will get to the robots. The code will get into the robots. Everybody's in a meeting. The code will get to the robot through the brain, right? And through the brain, we have. I'm trying to scroll up to that place. We have two ports in the brain of the robot. The two ports now. This is it. The two ports now. Two internal ports now. The first one is where you upload your code. So you use a USB code. Not direct USB code. There's a USB code, special USB code for it. You can see the ports here. So you connect these USB ports when you have written your code. So like now, when I have typed my code, I want to put this code now into the robot. So I will have to upload the code. This is how you upload it. I don't know if how many of you can see it very well. You can zoom in after the class. This arrow that goes to the right is upload. So when I connect my board, I click on upload. It uploads to the board, and every instruction that is in this, all the instruction here is being stored, will not be stored in that board at that moment. So that's how you upload your code. Then you can now remove it after it's been uploaded. After the code is uploaded successfully, you can inject it and connect it to power directly through the second port here. Okay, so Olarewaju Omoyi, I've answered the question. How can we get the link? Okay, does anyone ask a question? How do people code a robot? I just told you, you write your code, you write a program in Arduino programming language. Okay, so how can we get the link? The link to what exactly? The link to the class. Don't worry, the link to the record. The class is being recorded, so everything will be sent to the group after the session. Okay, so probably this night or tomorrow. Most likely tomorrow. You see the link tomorrow. Okay, any other question, please? Question. We have 3 minutes left. It's not Arduino, please. It's not Arduino. It's Arduino. What link exactly? The link to the Arduino. What do you mean to the Arduino? To Arduino what? I don't really understand what you're saying. The link to Arduino. What do you mean? You need to download the software. The software does not work without the hardware. So I'm not dwelling more on Arduino now, because you will need to buy the components, and I'm not ready to start selling components to you now, because there are levels to these things. We need to understand the basics of programming. This robot programming is advanced, so there are stages to each training. Do you understand? Stages to each thing. So I'm not ready to talk about that now. I don't know if I've answered your question, or pay me. Or Jesus, I can't pronounce someone's name. So please bear me out. Person that asked about the Arduino. Can we change a robot? What do you mean by can we change a robot? I don't know what you mean by can we change it. Can we charge? Oh, can we charge the robot? Yes, they work with power, so you can charge it. You can charge not charging the robot, you're charging the battery that is being used in the robot. Is the Arduino board compulsory? Of course, that is the brain. It's just like saying can you function without your brain? No, it's the brain of the computer. It's the brain of the robot rather. So the Arduino board it's not necessarily use the Arduino board, but you must use a microcontroller. That is what the robot understand. That's the brain the robot understand. That's the brain the robot uses to work. Okay, Mr. John Bolari, I've answered your question. Alright, thank you very much. Any other question, please? We have 1 minute, less than 1 minute. Any other question? Don't just raise up your hand. Miriam, your hand is up, but I've not seen your question. What's your question, please? I can't unmute everybody. I can't unmute your microphone. Please ask your question, Miriam. Adeniran. Please ask your question, please. Your question, your question, your question. If there's no other question, give me thumbs up, please. Thumbs up is another question. Thumbs up. Okay. John. Okay. Thank you. Thank you. So parents, and you, if if you're a child and your parents is not here, please tell your mommy and daddy that they should, or your guardian that is there, and you should please join for tomorrow's zone. Tomorrow's class is very very important. Tomorrow is the last day and it's just 1 hour. So please, and you, your child and your parent is not here, encourage your parents. Tell your parents to what, to join tomorrow's training. They shouldn't just come and give you the phone and go and do other things. It's just 1 hour. 1 hour is, I feel 1 hour is good enough a sacrifice to make. Okay, so if you know that question, I think we'll see us tomorrow. Please try and be here on time. Same time, 8 o'clock. I want to believe we all learned something. If you learned something today, you learned a lot today, give me celebration emoji. If you learned a lot, give me celebration emoji. Celebration, okay, thank you. Celebration emoji, okay, thank you, Mr. John. Celebration emoji, Mr. Friday, alright, okay, awesome, awesome, awesome. Alright, so thank you very much for your time. I really do appreciate. So I look forward to seeing you all tomorrow. Miriam, I don't know why your hands are being is raised. Alright, so I look forward to seeing you all tomorrow. Please, parents, once again, tomorrow is very important. Please all be here. See you all tomorrow. Bye.